Alright, hi everyone. This is Leetcode Weekly Contest 511. Uh, start to target an even number of moves. Next one. Uh, have a root, complete binary tree. Values gives you maximum on all nodes in the subtree. Number of dominant. Okay, this one's easy. So 5, 2, 4, 7, 1, and node 8. Um, okay, so we have val and then left and then, okay. Um, sure how to do this. DFS root, return answer. Okay. So basically you find the answer of the two children. So int max is equal to negative 2e9 if c left is not equal to no PTR max DFS c to the left if c to the right is not equal to no PTR max goes max DFS c to the right. If c dot val is greater than max, uh, it's equal. If its value is equal to the maximum value, okay. 5 and 4. All right. Next problem. Given binary string s, also given an array of strings strs, where source I has the same length as s, and consists of characters 0, 1, and question mark. Okay. Any subsequence sorted in non-decreasing order. Replace the chosen subsequence as a sorted sub. Uh, 0 or 1, otherwise return false. So you want it to change into S. That's true. Non-decreasing order. S2 stirs. Okay. 1 and it is true. 0, 0, 1. Okay, so I think I know I just have it. Okay, so I have an idea, so count 0. Right here. Say 0. And see return C0 less than or equal to C2. Uh, and C3. C1 is less than or equal to C3. Oh wait, vectorable? Okay, so um Oh. 101. 0, 1, C0, C2, and then C3 is string dot side, C2 is string dot side. 1, 1. Okay. 'True, false, true, and true. Not sure if this is passing now because it's kind of just guessing. Uh, so I'm guessing that if you have 1, 0, 1, anything, you can reach anything. So, okay, but this is just wrong, right? This is just wrong. If it's 0, 0, 0, 1, 1, and 1, 1, 0, 0, then it would be incorrect. So if it's 0, 0, 1, 1, and 1, 1, 0, 0, it wouldn't work. So it's probably like reading instead. You start over here, 1, 0, 1, 0, question mark 1. Okay. Uh, so um, if stri is equal to si, we can just continue. Um, so they're equal. Otherwise, right? If it's 0 and 1, then it's just not possible anymore. So if si is equal to 0, and okay is 1, okay is 0, you can break. Okay, otherwise you have a secret pointer while j is less than n and sj is equal to 1, j plus plus. Okay, and then if j is equal to n, okay is 0, break, swap si, sj, and yeah, and insert that pushback. Okay, and yeah, false, false, true. 1 question mark. If it's a question mark, right? Um, if it's a question mark, we can also continue. True, true, true. True, false, false. What happened here, right? 0, so 1 and then 0. If si is 0, okay, it's 0, break. We find at least J. J is N. Okay, zero break. Swap SI and SJ. Okay. Um, false. True, false, false, false. Last one, right? One. This is a one, and then this is a question mark. Just let the question mark be one. And then we have a zero, and we have a one, and then we say it's not possible. Okay, so instead, we should let this question mark be zero, and then we can swap these two. Okay. C1 plus plus, right? If you have a question mark, so zero, zero, one, one. So 1, 0, and then 0, 0 together, right? 1, 1, 0, 1. Let's C1 plus plus in the end over here. Size 0. If this is 0, if this is, let's continue. Um, right, you always want to use the need. True, true, false. 1, 0, 0, 0, question mark 1. So 0, question mark, 0, 1. Okay, so you have a 0, and you have a 1, 0. So those got canceled out. Choose N, C, and N. Okay. C and C. Oh, we don't need this chain anymore, do we? Okay, so you can choose for C, you can choose. For N, you can't choose. N has to get paired with either a C or a N. That was actually worse. Oh yeah, because 1, 0 is in the back. They can't. You have to be paired with um previous ones. Okay. Why don't we just reverse it? So 0 has to be paired with something in the front. Um, and then N. Okay, so if it's 1, has to be paired with something in the back. Okay, I'm gonna use this one because I feel like this one's close also. Actually, just this is fine. So if it's a question mark, C0 plus plus, otherwise C1 plus plus. We won't need C1. Yeah. We won't need C1 else. C0 minus minus. Please need zero. Need zero minus minus. Right? Yeah. 0, 1, and then 0. Yeah. Okay. 0 question mark 0 1. 1 question mark 1 1. Okay, so if you get a 1 and a question mark, basically you have a C1. C1 and need 0. Okay. C1 and need 0. You want a stack, right? Okay. Now for C1, you want a queue. N0 C1. Actually, just say stacks. Um, um, true, false, false. Alright, nice. That wasn't that bad. Only 2 wrong answers. Uh, 23. Okay. So just focus on array of strings words. Define the transformation on a string S as follows. Let E be the subsequence of characters at even indices of S. Let O be the subsequence of characters at odd indices of S. Independently, cyclically shift E and O any number of positions to the right. Construct, okay. Partition words into the minimum number of groups such that every string belongs to exactly one group. Every pair of strings in the same group are equivalent. Okay, let's see. N, G, Z, T, W, G, Z, T, W, A, B, C, C, B, A. So, okay, B, C over here. 10 to the 5. So I think ESU actually. Okay. And we use a map string. Where does that leave us 5 times 10 to the 5? So if I want to store that, no, I don't know what. Oh, the sum does not exceed. Okay. So yeah, sure. Alright, and we can just use a disjoint sets. Um, Smaller than estas. Smaller than. One, three. Okay. Wrong answer. What? Come on. Oh wait, you can only shift them. Oh, I see. I can't sort them. Shift S1 and Shift S2. Okay. So we can perform string shift. What's this? Um, Line minimum resulting string after rotating current string. Or end time. Min cycle. N and G. EW. I get N, G, and GZ. Oh, wait. My God. Z and G and NGZ. 1, 0, 2, 1. Shift 1. So 'Alright, good. Um, okay, I guess. That was kind of slow though. Um, I feel like a bunch of people just cheated, so it's alright. 668? Not bad. Okay. So solutions. Um, I'll try to be very specific and detailed because there's a lot of time left. It's like an hour left, so I'll spend maybe 5 minutes or up to 10 minutes on problem. So problem A. So, in this problem, basically, you have a knight and then it's moving to some squares. You have a start, you have an end. You're just asked if you can move a even number of moves to get from start to target. So basically, something you notice, right? When you move a knight, it goes one space and two spaces, right? Like two spaces, one space. It always goes three spaces. So basically, the sum of x and y, the party of x and y, changes every time you jump. Yeah, every time you jump, your party of x and y changes. So basically, if you jump an even number of jumps, the party of x and y will remain the same. So I have to check if the party between the distance of these two are equal, or just the party of them are equal, right? I just use a distance; it's the exact same thing. So from start to target, you need one in the x and one in the y. So that's a sum of two. It's even, so it's valid. For this one, you need two in the x and one in the y. So 2 plus 1 is 3. It's odd, so it's false. Yeah. Because it's guaranteed that you can always move from one space to another. Um, okay. So go to the next problem. Okay, so this is just a simple DP on tree, and you don't even need DP actually. Basically, you have your DFS, you have your current node, right? Um, you have your current max, you have the subtrees max. So you find the subtrees max. If the left child is not no PTR, you can just max equals max max and DFS C to the left. And DFS returns max value being sub 3 of C. Okay. Right. If the right value of C is not LPTR, so there exists a right child, then you can DFS on that one, right? And you have your new max. Okay, and then in the end, if the current value is greater than or equal to this max, answer plus plus, right? That's just what the problem's asking for. And then you can just return the maximum of max and C val, because that would be the new maximum. And then you start DFS at root, and then you return answer. So yeah, simple, pretty simple. Just a DFS on tree. And then next problem. So this one, right? Okay. Uh, First I'm gonna try to clean this up a bit, right? Because it's not very clean right now. Um, I mean, basically it's just this. There's nothing special about it, I think. Okay, so I'll just go over thought process really quick. So basically, I go from back to front. You can probably go from front to back also, but I use back to front. So basically, at every step, if they're equal, you can just continue. You don't have to account for this one. And then, first case, if string I is equal to this question mark, right? So then, if first I is equal to 0, then choose 0 plus plus. So basically, if it's 0, right, we can choose 0, 0, or it can become 0, 1. So C0 is just a number of possible values of these, because 0, 1 can be paired with 1 and 0 later on, which is good. We want to pair them up. So we have this. Otherwise, we have our C1 dot push I. So what does this mean? C1 just means 1, 0, right? The amount that's 1, 0. And we store the indices of these. Because 1, 0, um, 1, 0 can only be paired with 0, 1 on top, right? Uh, yeah, I think so, yeah. Um, and then otherwise, if it's not, for the question mark, the first case is if it's a 0, right? Then n0 dot push I. So n0 is the ones that need something to go with it, right? So right here, if 0, 1, um, 0, 1, it has to be paired with a 1, 0, right? And that's just our C1. C1 is 1, 0. So basically n0s must be paired with C1s. Okay. So I push this thing over here. Otherwise, right, if it's 1, so if the current is 1, 0, then first of all, if n0 is not empty, you can just pop it, right? You can just pair it with the 0, 1. Otherwise, we do C0 minus minus, because C0 is the one of um zeros and ones, so we can pair it with this 1, 0. If C0 at that point was 0, right, then we can't pair it with anything, so okay, 0, we break. And then over here, once we do the whole thing, all n0 dot empty and not c1 dot empty, we take the top of them, right? C1 dot pop. If I2 is less than I1, n0 dot pop. What does this mean, right? Remember C1 is 1, 0, so this is I2. And I1's over here, right? 0, 1. If I2 is less than I1, so I2 comes before I1, we can just pair these two together and we'll be fine, right? We can just pair these two together and it'll become 1, 0, and 1, 0, and we'll be done. So basically, we just C0, C1 always pops, and then we just see if it's less than. If less than, n0 dot pop. If n0 is not empty, then okay is false, and then answer dot pushback okay, and then in the end we can just return answer. Um, we actually don't need this current s. Let's use s is fine. Yeah, so this code should be okay. Yeah. Okay, so next one. Okay, so this one I don't really like because it's just plain implementation. So basically, when I saw this problem, basically, first of all, I just thought, just sort all the strings, and then find the strings that are equal, and then those form a cycle together, right? Those are connected together. So basically, I'll just go over the first part, right? For every string s, so this is the first part where we have to sort them. Orig is the sorted string. Um, you take the even, you take the odd and the even, and then basically I just searched something up. Um, so what was it called again? It was the lexicographically minimum string rotation. So I just searched that up. I found this thing. I used them on this S1 and S2. And then I sorted them. I rotated them using this, and then I make the sorted string. So all of these just find the sorted string, which is OREG. Okay. Um, and then next, right? So now you want just the strings that are equal to be together, right? So just count how many there are. Actually, we can just do this set. We don't even need a DSU. So you can just use a set, right? Just use a set string st. And then over here, just st insert, and then over here, return st dot size. And you don't even need its DSU. That was overkill. Right, let's see if this works. Uh, yeah, this works. Okay, so basically, over here, find all of this is just finding the string, the sorted string, and then you insert this into a set. And then in the end, just output how many elements are in the set. Because once you sort them, all the strings that are equal we'll just group them together, and then we're done. Yeah, so simple. Just plain implementation. I don't like this problem. Shouldn't be a legal part actually, because you can just search up, and then you can answer. So yeah, uh, this is my contest. Did okay. Yeah, I did okay. Probably gain rating. So yeah. Um, that's it. Don't know how AI is doing right now. Yeah. Okay. So I'll see you all next time.